Lesson 5.5 is on proportional and non-proportional relationships. In this lesson, you will identify proportional and non-proportional relationships in tables, and you'll also be able to describe a proportional relationship using an equation. Remember, the essential question for Chapter 5 is how can you identify and represent proportional relationships? For Lesson 5.5, there's a couple of vocabulary words. Two quantities are proportional if they have a constant ratio or rate, and then that constant ratio is called the constant of proportionality. And we also have relationships when the ratios are not constant, and in that case we'll call them non-proportional, which makes sense because the prefix non is not. So this is a pretty easy concept to start off with. Something you'll have to get used to is that some of the tables are written vertically and some of the tables are written horizontally. So in this particular table, we have the X value as the coffee in pounds, and then the Y value is the cost in dollars. So we also sometimes say that this is the input, the X, and the Y is the output. We've also talked before about the domain and range, and those words will also come up again. So domain is the X, and the range is the Y. And even further, we sometimes call X the independent variable, independent, and the range or the output is the dependent variable. And that makes sense. The cost depends on the number of pounds that you purchase. Okay, so again, get used to tables being written vertically, but then also horizontally here. So we have the number of spiders is our X, and the number of legs is Y. And we can find out back up here to the top, the constant of proportionality by taking the Y value divided by the X and seeing if we get the same number throughout all the data points. So in this case, 8 divided by 1 is 8, 16 divided by 2 is 8, 24 divided by 3 is 8, and 32 divided by 4 is 8. And it makes sense because spiders consistently have 8 legs. And so in this particular problem, is the relationship proportional? Yes, it is. The constant of proportionality is 8, and then your reasoning, each rate is equal to 8. Okay. At the top of page 207, we're looking at another problem. In this case, we have a vertical table, still X and Y, and then we have a horizontal table here. Okay. Now sometimes you can just tell by the situation. For the last problem, the number of spiders and the number of legs is most likely going to be proportional because every spider has 8 legs. But in this case, the number of ice cubes proportional to the number of drinks, well, we know that unless someone's counting out ice cubes and making sure every drink has the same number of ice cubes, it's probably not going to be exactly proportional. There might be a relationship, but we're not going to have a proportional one. So what we're going to do is take this table, take 6 divided by 1, 14 divided by 2, and 22 divided by 3. We don't get the same one number each time, so we will say that that is not proportional, and that the reasoning is because 6 over 1, 14 over 2, and 22 over 3 are not equal. So it's non-proportional. For the next problem, we are going to look at a relationship in the form of proportional relationships. And this formula right here, y equals kx, is the formula for proportional relationships. And we also call that a direct variation. That will come up again. But just keep that in mind. We have lots of different terminologies and words to use for things in math and a way to represent them. So I'm just trying to give you a heads up about what to expect in the future. So y equals kx is an equation that we can use where k is that constant of proportionality. So if we're looking at the example 3 below, We start with what we know, and that is the formula. In this case, this is the same thing as y equals kx. All we did was change the y to a c and the x to a d. And the diameter, the x value, is independent, and the circumference, the y value, depends on whatever the diameter is. So again, I'm just trying to use those vocabulary words that are going to come up again for us. Y equals kx is the format that we're going to use. This one's just a little bit different because we're using circumference and diameter, but don't let that confuse you. We will use y equals kx in the example that you're going to write down in your notes. And so I'd like for you to do in your notes is to write down y equals kx. And in this problem, it doesn't give us a table, but it does say the cost for 2.5 pounds of meat is $7.20. And so in this case, the cost is going to depend on how much pounds are purchased. And so if I'm going to make that into a table, the pounds is the x value and the cost is the y value. So my y value is $7.20 and my x value is 2.5 pounds. So again, if you start off by writing the formula y equals kx, then we can substitute in the numbers. $7.20 equals, we don't know what k is, that's what we're solving for, and then for the x we're going to put in 2.5. Now to isolate the x, or in this case the k, we want to divide both sides by 2.5. 2.5 divided by 2.5 is 1, leaving k by itself, and 720 divided by 2.5 is 2.88. So we would say that 2.88 is our constant of proportionality there. So that means that each pound is $2.88. So the formula that we would use to write that is y equals 2.88x. All I did there was take the 288 and substitute it back in for k in the equation. Now that I know the formula, I can plug in the number 4 to find out how much 4 pounds of meat will cost. So 288 times 4 gives me $11.52. So the constant of proportionality was 288. The cost formula, or if you will, equation, is going to be the cost equals 288W. Notice there they didn't use my same variables, x and y. That's totally fine. Just like up here, we didn't use x and y. But just to keep things straight, you can always use x and y if you want. And then we can plug in any value for x to find out the cost. Okay? We'll do some more of these in class, but again, that's enough to get you started, hopefully, and get you through the worksheet. And like I said, we'll do some more in class, and you can always email if you have questions.